Yeah, please, ma'am.
System is a set of components that is working together for the betterment of mankind. Okay, so transportation can also be considered as a system. So it provides safe, rapid, comfortable, convenient, economic, and environmental friendly way of moving people. So considering the means or modes of transport, we have different means by which we are traveling, right? So if you are going by car, so you are going on the road, so it is roadways. Whereas other means is if you are going in a train, railway is the means. Okay, so depending upon the mean or mode, the transportation can be classified for roadway, railway, airway, and waterway. So in transportation engineering, one you will be seeing roadways and airways, and transportation engineering two you will be studying railways and waterways. So in today's class, I'll be concentrating on the roadway part. Okay. Sorry. So road transportation, broadly I can classify or I can say like it consists of traffic engineering part and the pavement engineering part. So traffic engineering, in your first and second module, you have seen the geometric design and what are the various factors that control the design. You might have studied the different traffic characteristics that is influenced in the design of the geometric design of highways. So another part is intersection design. Okay. And moving on to the pavement engineering part, we will see the different type of materials that is being used for pavement construction, what should be its desirable properties, and what are the different design methods that we use, how much thickness we need to provide. All these things comes under pavement engineering. So we will focus on the traffic engineering part. So this is a traffic corridor. Okay. So I have given here three sections, basically. So this is the intersection part that we will be seeing today. And in a traffic corridor, it consists of mid-block intersection. And there is a zone coming in between this, which is known as a transition zone. So why this transition zone is being provided? For example, you are driving your car through a national highway. You are free to drive the desired speed, right? Unless otherwise some kind of accident or some kind of incident happen, you are almost free to drive. Whereas if you are nearing an intersection area, you're always vigilant. Like I have to reduce my speed, I have to stop my vehicle if the signal is red, or if the police person stops me, I have to stop my vehicle. So when you are entering into the intersection area, you become more vigilant. So there is this transition zone where you are reducing your speed, you are decelerating your vehicle, and in the intersection area, you will stop the vehicle. And what happens when the signal turns green? You will slowly accelerate and then move to the next intersection. So mid-block is almost kind of free movement happening, or it's a kind of car following happening, or acceleration models are applicable there. Whereas in the intersection area, depending upon the control system, you may have to slow down your vehicle, be in the queue, and then once you get the right of way, then you will enter into the intersection. So transition zone comes in between these two, where a lot of maneuvers happens in the transition. For example, in the intersection, I'm coming through the mid block, I want to turn left. So what we do? We will move our vehicle to the left side. Okay. So a lot of diverging, merging movement happens in the transition zone. So intersection is basically where two or more roads join or cross each other. So you will see what where it is white line intersection. So it's an adoptive picture. But what happens if there is, like, if I see this intersection, the traffic can go up to say 60,000 vehicles a day, or maybe 6,000 vehicles an hour. So that much heavy traffic will be there. So what happens if there is 6,000 vehicles an hour? 1 minute there will be 100 vehicles. So if that is the situation, how to control the vehicles that is entering into this intersection area? If it is a small intersection in the residential area where we are, or in a rural area where there will be only one vehicle coming in, say 5 minutes or 1 minute, only one vehicle will be there. So those vehicles themselves will make decisions and they will move accordingly. Whereas here, in 1 minute, there will be 100 or 150 vehicles arriving. So in that situation, we cannot assume like the drivers will control themselves. So then, there in these situations, we have to have some controls. we will see
Excuse me,
what
ma'am.
are the different types of intersection.
Excuse me, ma'am. Sorry for interrupting. Ma'am, actually your voice is breaking. Ma'am, are you actually using a headset right now?
I'm using headphones. Yeah.
Okay, ma'am. If you could hold your mouthpiece a little more closer, maybe.
Is it okay now? Clear?
Ma'am, can you speak again?
Change the headset. Can you hear me now?
Yeah, it's okay, ma'am. Continue, ma'am.
Thank you. So let's see the classification of intersection. Okay. So basically, intersection can be classified into two. One is at-grade intersection, where the both the roads are meeting almost at the same level. Okay. Whereas in the case of grade separated intersection, the roads or the approaches coming to the intersection area, they are meeting at different levels. So one road may be going above the other, one may be going below the other one. So that is what is known as grade separated intersection. So let's see, or let me define what are. So there are here in this picture, can you see? So the major road is meeting with the minor road. So a vehicle is coming here, going through the intersection area and then leaving. So here I have to say what is approach vehicle. Okay. So from the portion where the vehicle is entering into the intersection area, that is what is known as the approach vehicle. And the portion through which it is leaving the intersection area is what is known as departure. So depending upon the number of legs in an intersection, we can classify it into different types. One is if there are three approaches, so it will lead to a T-shaped intersection. So here it is meeting at right angle. Whereas if it is meeting at an angle other than right angle, it is a square T. Whereas if it is all the three are meeting at some angle, it will lead to a Y intersection. In the same way, there are four approaches. Right, meeting at a right angle will result in this kind of intersection. If there is some offset between them, so it is an offset kind of intersection. There can be oblique kind of intersection, and if there are more than four approach roads leading to the intersection area, you can have another type of intersection, 5 or 6-legged intersection. So now let's see. A major road is there, another minor road. So a vehicle coming from the major road, he has the option of going either straight or he can move left or he can move right. In a similar way, the vehicle coming from the other direction, opposite direction, he is also having the freedom to move straight or right. So what happens? If these are happening simultaneously, then that will lead to collision. So these lead to points of collision. So let's say two streets are meeting. Then how many conflict points will be there? Yeah, around 32 conflict points will be there. Okay, so these conflicts can be intersecting conflicts. The conflicts will happen when the wave is merging into a particular stream. Then the accident can happen or conflict can happen when it's diverging from a stream. Okay, so there is 32 potential conflict points which can lead to a probable accident. So how can we avoid this? Before that, let me say what are the different maneuvers. Okay, different type of conflicts can be a direct conflict when both are meeting at right angle. It is a direct crossing or it can be a skewed crossing, and there can be diverging. So from a stream, it can diverge into different streams. And there can be merging, that the vehicles coming from different directions can merge together to form a single stream. Then there is another type of maneuver which is weaving. So it can be the combination of merging and diverging. Okay? So vehicle merge together and then it will diverge. So we can classify the intersection at grade intersection based on what kind of control strategy is being provided. So it can be unchannelized intersection, usually which we provide in unimportant roads. Like for example, it is a local street in a residential area. It is unchannelized intersection. Then another way of controlling is by channels. We are segregating the traffic. This channelized intersection. Then next is rotary intersection. We are providing a rotary island at the center and the vehicles are made to move around this rotary. Then another way is by providing signalized intersection. So this is an example of unchannelized intersection. This is an intersection at Mumbai. You can see there is no kind of channelization being provided. No control system is there, so vehicle can move in the way they want. Freedom is there. So it is one way it is advantageous, they can move in the way they want. But another thing is if the vehicle is too high, then that will lead to accidents. A lot of confusion will be created. And if some kind of congestion happens or traffic happens, then to clear this will take a longer time. Okay. So this is the lowest class of intersection. It is easiest to construct. There is nothing complex in that. But traffic operation is complex. The next is channelized intersection, where we can channelize the traffic or we can segregate the traffic into different directions. So by providing traffic islands, we can segregate the vehicles into different directions in which they want to move. Okay. Either we can provide traffic islands or we can provide pavement markings, and then we can segregate. So I'm just having a comparison at a T intersection. If no channels being provided, then there will be a lot of potential conflict points. Whereas if a channels or channelized way, we can segregate the traffic can smoothly move through this intersection. So this is a comparison between a four-legged intersection, channelized and unchannelized. The next is rotary intersection. As I told you, in the case of rotary intersection, there will be a center island. Okay? And the vehicles entering into the intersection area will be moving in the same direction and then diverging from this intersection. So it will be made to move in a particular direction. Mostly it is made to rotate in the clockwise direction around this center island. So what is the advantage of this rotary is? You can see here. In the case of conventional intersection, there will be 32 kind of potentially conflict points. Whereas in the case of roundabout, the conflicts are getting reduced to only 8 number. So that is the advantage of roundabout. So let's see design elements of roundabout. So in the case of roundabout, what we are doing is we are making vehicle, for example, a vehicle coming from this direction. Priya, excuse me. Hello, Priya. Hello.
Yes, ma'am. Hello. Ma'am.
Can you see my mouse moving over the picture? Or I have to annotate, then only it can be seen.
Okay, and it's not. Ma'am, can you move the mouse once again?
It's not visible. Yeah. Is it visible? Should I annotate and then leave it?
Ma'am, can you try annotating? Because I guess the signal strength there is a bit weak.
Is it moving? Can you see?
Can you try it once again?
Yeah. It's okay.
No, it's not.
Okay. So
Yeah.
it's not working.
It's
But
not
when
working.
annotating, I cannot change my slide. That's another issue. Fine. It's okay. So a vehicle entering into the intersection area, it can either move straight, left, or right. But here, it's not directly going into the right direction. It has to go around the side, and then only it can diverge from this intersection. So, what are the different design elements here? One is the entry width. Okay, the width of the approaching entry, the width of the approach. Then there is this radius, entry radius to be provided. Okay. Another feature that we have to consider is say for example a enter into through the from the left side. Okay, so in this weaving length portion, it will be diverging into the stream. If it wants to go out, it can it will be merging and then diverging. So a main feature designed is what should be the width of this weaving section, what should be the length of this weaving section. Then another to be designed is the radius of the central island. So the radius of the central island is usually being kept as 1.3 times the entry curve. Another thing is the exit radius. So the exit radius always to be provided more than that of the entry radius. Why? Because more if the entry radius is more, sorry, exit radius is more, then more number of vehicles can be discharged because it can travel at high speed, right? So that is why these are different features to be considered. So moving into yeah. So let's see a numerical example for this rotary intersection. What is given as this the volume coming from all the approaches are given. For example, if you are considered from the side, from the west direction, 1,405 vehicles are coming. 400 vehicles are moving towards left. 505 vehicles are moving straight. 510 vehicles are moving right. So this is the traffic, the demand of the traffic demand in an intersection. If this much traffic need to be handled, what should be or we have to design the capacity of the rotary. So what is being given is the entry width and the exit width of the rotary is being provided. Okay. Then another thing that is being given is the width of the carriageway is also provided to you in the question. So you are asked to find the capacity of this rotary intersection. So it's usually been asked in the university to design the capacity. So step one is we have to design weaving width and the weaving length. So here E1 and E2 are the inputs. So if I consider this weaving section is here. So this weaving section, the two features we have to design is the length of the section and the width, because the length of the section is actually affecting the operation features of this rotary, because through this length the merging and diverging movements are happening. So we have to design how much is this length, and then we have to also design how much will be the width. So if the entry width are known to us, E1 and E2 are the entry width of this particular weaving section. So what we have to do is we have to provide the weaving width one lane extra than the average entry width. So E1 E2 is by 2 will be the average width plus 1 width extra. Then usually the length of the weaving section should be kept very much higher than that of the width. So usually the factor being used is the length should be 4 times the weaving width. Then next factor to be found here is how much proportion of traffic, weaving traffic is there. Okay. So here if you see, there is traffic A, B, C and D. So A, if you see, it is moving through the innermost lane. D is moving through the outermost lane. That is B and C, they are merging and diverging. So that is the weaving section. So if I want to find the proportion of weaving traffic, it is B plus C divided by the total traffic in that direction. If this is the traffic given to you, you have to accordingly draw this particular diagram. For example, if you consider the vehicle coming from the west, there is 1,405 vehicles. Okay, so let's consider 400. So 400 is directly moving to north. So you can mark it in the leftmost side. Then let's consider the next one, 505. Okay, it is moving towards east. So can I directly move towards east? No. It has to turn around, or it has to move around the island. So it has to move first in the northwest direction, then in the northeast direction, and then it discharges from the east direction. Okay. So what happens? This 505 is getting added here and also in the northeast direction. Whereas if I consider the 510, which is going to the south direction, can it directly turn towards right? No. It has to go around the rotary, right? So it will be first moving in the northwest direction, then the northeast direction, then the southeast direction, then only it can. So in this way, you have to find how the vehicles, the traffic entering into the intersection area has to be appropriately segregated in the way it is moving. Once you do that, okay, then you have to find the proportion of weaving traffic. Okay. So if I consider in the northwest direction, say how much is waving traffic. You can see 505 plus 510 and other one is 600 plus 350. So that much is the waving traffic. They are merging and diverging. So that is why it's going to wave. And how much is the total traffic there or the total vehicles passing through the northwest direction? It is 400. So to this waving traffic, I have to add this 400 and 370. 400 is moving through the leftmost lane and 370 is moving through the rightmost lane. Okay. So by doing that, I'll get the ratio. So I can get the proportion of waving traffic in northwest direction, northeast direction, east-west direction, and southwest direction. So, of which, of all these things, for which should I design? I should design for the maximum value. So, when I compare between all the four, the maximum is 0.783. So, that need to be picked. And then, this is the equation to find the capacity of the rotary intersection, which is being formulated by TRL for the Transportation Road Research Lab. Okay, so this is the equation being given where W is the width of the waving section, E is the average entry width E1 plus 2 by 2, then P is the proportion of waving traffic, L is the length of waving section. So all these things I have mentioned to you, or I have explained to you. So you can substitute all those values here. So finally you'll get the capacity in southeast direction, or that is where E is maximum. So it will be 2161, or I can say 2162 vehicles per hour. The next is hierarchy of intersection, grade intersection. So they are, as I told you, at grade means they will be at the same level. So, what is the, or how can I rank it? Okay. So, what is the lowest form of intersection? It will be no control. There won't be any control. So, that is the, if I consider according to the hierarchy or the ranking, it can be no control, there can be partial control, there can be time sharing, there can be space sharing. Okay. So uncontrolled, priority intersection, rotary intersection, and traffic signals. So rotary means we are sharing space, whereas signal means we are sharing the time. So first we will see the uncontrolled intersection. So uncontrolled intersection means there is no means of control. There won't be any control system there. There's no control at all. So how can I decide whether I can enter or not into that intersection? It is depending upon certain rules to be followed. One is before, means first in, first out. Then always left is given priority. Another thing is when designing this intersection or when checking whether it is safe or not, we have to see whether minimum side distance is available or not. So let's see this particular intersection where there is no means of control. So there is vehicle B1 and B2 coming from two approaches, say A to be the major road, B to be the minor road. So what happens if both these vehicles are not stopping? Both are deciding like, yes, I have the right of way to enter into the area, intersection area. Both will be proceeding and finally they will come and collide at this point of collision, right? So, yeah, what is DA? DA is the minimum side distance required. So side distance is the minimum distance required to stop the vehicle without colliding with any obstruction on the road. Okay. Same way I can mark the other to be DB, or the side distance availability in the minor road. So why this particular triangle is being created here? Because there is an obstruction. It can be a building or it can be a hoarding being provided by the side of the road, which restricts the visibility. So because of that, because of this restriction in the visibility, you are forced to provide, or you have to check whether the vehicles which are coming in these two directions, the speed at which they are coming into these from these two approach legs, the speed at which they are coming is safe or not. If they are coming at higher speed and if it doesn't have proper visibility, both are coming at the same speed, finally they may lead to collision. So we have to check the criteria. Okay, so let's A be the offset from road A or right from the leftmost lane of one approach, and similarly B be the offset from the leftmost lane from the other approach. Okay. So it's basic geometry. You can get the triangle, and from the similar triangle you can formulate the equation as dA by dB is equal to this triangle. If I consider dA minus B by A and B mul dB minus A, or from which I can find from the actual field condition, I can find what is actual dA available on the field. Okay, so this is what is available. Can you see on what basis I should check the safety here? I have to see whether this dA and dB that we are finding is more than the stopping side distance. Stopping side distance is nothing but the minimum side distance required for a vehicle coming at a particular speed to stop the vehicle without colliding with another obstruction on the road. So when, according to the visibility criteria, if you find dA and dB, then you have to check whether it is more than the stopping side distance. Otherwise, it can lead to collision. So if some obstruction is restricting the visibility, that need to be removed. Okay. Next is yield or give way sign. So this is priority intersections. So this sign is mandatory sign. So if you see this sign on the road, it's your responsibility to act accordingly. Okay. So if give way sign is being seen on the road, then you have to prepare to stop if necessary. Okay. If some vehicles you see, you have to, if this sign is being shown to you, you have to stop, or you should prepare yourself to stop your vehicle if another vehicle is approaching from the other road. Okay, so you are yielding the right of way to the vehicle from the other side. Whereas stop sign, so once stop sign is being shown, a particular approach leg, then it's the responsibility of the driver to stop his vehicle at whatever the condition is. Whether the vehicle is present or not, it's not, you don't have to consider those things. Whenever he sees stop sign, he needs to stop his vehicle. That's why it's called mandatory signs. So for example, if there is a major and minor road, so one is, say, for example, one is an arterial road and another one is a local street. Subarterial meeting a local street. So subarterial will be the major road and minor road will be the local street, right? So always we give importance to the major road. So in that case, where will we put the give way sign? For the minor road vehicle, we will put the stop sign. So he has to stop his vehicle at whatever the condition. For the major road, we will be providing give way sign so that he can accordingly act. Okay? So if he sees the give way sign, he will reduce his speed and he will approach the intersection area. If there is no road, there is no vehicle coming from the minor road, he can directly enter. Otherwise, if some vehicle is coming from the minor road, he has to give way to the other vehicle. Okay? Whereas if it is two major roads meeting, we have to give importance to all the roads, or we have to give equal priority to all the roads. So we have to put stop sign, or every vehicle coming from all the approaches has to stop and then decide accordingly. Then obviously I told you what is rotary. It is kind of space sharing. Okay? We are sharing the space between the different vehicles in the traffic street. And another thing is time sharing. So say these vehicles are entering into the intersection area, both are thinking like they have the right of way to enter. So what happens? It may lead to accident. So to avoid that, what we can do is we can share the time between these two vehicles. So one we can give green, which will permit it to enter, the other will be red. Then again we can turn the signal so that the vehicle on the one road can move, the other can wait. So that is what is traffic signal, where it is the most effective and flexible way of controlling the traffic. Okay. It is a means by which we are sharing the time among the different approaches. So it will alternate the right of way according to the display lights provided. So the standard color is red indicating stop, amber indicating to slow down, and green indicating that we can proceed. So just for fun, I put this. In India, we have a practice like even if it is red, we always look for it. The traffic police is not there. We have a tendency to enter into the intersection. So, what are the advantages and disadvantages of traffic light? Being a regular driver, what do you feel? What are the advantages? Yeah. Traffic signal, it provides orderly movement of traffic or a disciplined movement of traffic. Okay. Then obviously it can minimize the conflicts or the potential conflicts can be minimized. And thereby it can increase the capacity. Okay. Then, as I told you, if a major road or a minor road is meeting a major road, the traffic in the major road will be very high. Okay. So the vehicles coming on the minor road may not get opportunity to enter the intersection area. So in that case, the traffic signal can accordingly stop the vehicle on one approach light and give way to the other vehicle. Okay, in the minor road. The next is coordinated continuous movement of traffic can be made possible through traffic signal. For example, there are intersections coming one after the other in a successive way. So we can provide traffic signals or we can provide the signal system in such a way that we can have a coordinated movement or continuous movement of vehicles from one intersection to the next intersection to the next intersection. Because when you start from one intersection and reach the next intersection, there the traffic light shown will be green. When you then you can proceed, and when you reach the third intersection, there also it will be green. So that will enhance the continuous movement of vehicles. Then, if it is, it can improve the driver confidence. Like if its traffic signal is there, you can very confidently enter if it is green. So you are very confident that the other vehicles will be waiting there. So that will improve the driver confidence. So thereby we can operate at capacity. Then the disadvantages are sometimes introducing the traffic signals can lead to increased delay. Okay, so if one is provided green, the other vehicle has to stop there, right? So that will lead to delay. Then another thing is certain type of accidents probability increases. For example, merging kind. There is free left turning, so the vehicles will always take a free left, which can lead to a diverging and merging conflicts. Okay, so this can lead to a certain type of accidents. Then if it is not being properly implemented or installed, it can lead to unnecessary delay. So these were the disadvantages and advantages of traffic lights. Let's see the definition and notation. The four-legged intersection. The vehicles are coming from all the directions. It can move straight, left, or right. Then next we will see what is a signal phase. Okay. Signal phase means the total signal time we can divide among the different available, or the total time we can share among the different vehicles coming from all the approaches. Okay, so here I can say, like in phase 1, the vehicle 3 or the vehicular movement in direction 3 and 4 is permitted. Okay. Or I can say in the east-west direction is permitted, whereas in the north-south direction is stopped. Whereas in the second phase, the north-south direction movement is being permitted, the other is being stopped. So that is what is called as phase. Okay. So phase is a part of signal, a part of cycle length allocated to a travel movement. So allocated to a traffic movement, receiving the right of way. So during green interval, we will be allocating non-conflicting movements to happen. So the green interval, we won't allow the conflicting movement. We'll always take care that the movements happening there at that green time will be non-conflicting movements. And explain to you here, if I say 3 and 4 is happening at the same time, if I'm permitting 1 and 2, what happens? Then that will lead to crossing conflicts, right? So in a particular phase, we will permit only non-conflicting. So I can divide it into 2 phases. Another way of providing is depending upon the approach length. Say from north, I can provide for the vehicles coming from north, I can give one phase. Vehicle coming from south, I can give another phase. Vehicle coming from east and west can be given separate phases. So that is another way of providing phase. Another third option is straight through movement can be permitted. Like For example, east, west, north, south is permitted. And if the right turning movement or the right turning traffic is high, then the right turning traffic can be segregated into a different phase. Okay. So there are several options by which we can is the phase. So let's consider phase A. So first we have the green time, then we have the red time where the vehicle on the other road will be permitted. Okay. So there is from green to red there is a transition to yellow. So for example, if a vehicle has already entered the intersection area, we must give them opportunity to clear the intersection area for which we are providing this yellow time. Okay. So for phase A, there will be green followed by red. In between, there is yellow or amber. So if I consider phase B, okay, in phase A, during green and yellow time, vehicles are permitted to move. Right? So what happens in phase B? That's a particular time will be red for phase B, and after that it will be green and again amber. So the same time that for phase A will be red. Then in certain signals system, there will be an all red period provided at the end of each cycle so that if somehow any vehicle got trapped inside the intersection area, this will provide or this will give them an opportunity to clear the intersection. This is what is all red period. This all red period can also be used for the pedestrian to cross the intersection. Okay. The road users, pedestrians are also road users. We should give them opportunity to cross the road. So during the all red period, the pedestrians can cross the road. So this much is the cycle length, which is being divided or which is being shared between two phases, phase A and phase B. So if I consider phase A, first is green, followed by amber and red. Similarly, for phase B, red, green, and amber, there is an all red period also. What are the different terms? Cycle is one complete sequence of indication. Okay, so it's green, yellow, red. For one phase, if I consider a green followed by yellow and red. So the time required for this whole indication is what is a cycle. Okay. Cycle length is a time in seconds that takes a signal to complete one full cycle. For example, if green is shown to the vehicle coming from north direction, then it will turn into yellow and red. Then comes again green. No? So it is actually the time difference between one green to the next green, or one yellow to the next yellow, or one red to the next red. So one complete sequence of indication, or one complete sequence of all these indications is what is called as a cycle, and the time required for this is what is known as the cycle length. And cycle time, we cannot go on increasing the cycle time. So it has to be the maximum limit permitted is only 2 minutes or 120 seconds. Okay. And normally the cycle time varies in the range of 30 to 90 seconds. Usually, if we are getting that in decimal, we will round it off to the next multiple of 5. Then interval. So what are the different intervals that is being provided? There is red interval, there is green interval, there is yellow indication, there is all red indication. Okay. So green interval is a time where the movement of vehicles are permitted for a particular phase. Red interval is for that particular phase, the movement will be restricted. So when it is red for one phase, for the other phase it will be green. Okay. Thereby we can avoid conflicting movements. Then there is change interval. Okay. So it can be the sum of yellow and red time. Then what is loss time? So you can see here from red to green when you are moving. For example, you are waiting in a queue. Okay. So when the signal turns to green, all of a sudden can you enter into the intersection area? No. It requires for you to react to that situation. For every human being, there is some reaction time required, right? So once it turns green, you have to react to the situation, you have to accelerate your vehicle and then enter into the intersection area. So there will be some amount of initial loss. Okay. So that varies depending upon your position in the queue. The first vehicle, there will be some delay. Second vehicle, from the time it turns into green, the time lag between the time when the signal turns green to the vehicle when it's enter into the stop intersection area, when it's crossing the stop line, it's what is called as the initial loss time. And then there is clearance loss time. So what will that be? Clearance loss. For example, there are two persons. One is a conservative driver, another one is a rash driver. So when the signal turns yellow, okay, a conservative driver will be slowing down his vehicle and wait. Whereas if another one is a rash driver, even if it is yellow, he will take that opportunity or he will utilize that opportunity to cross the intersection. So there will be the different characteristics depending upon the type of driver. So some driver may cross, some may not cross. So there will be a clearance loss time at the end of yellow period. Okay. So the total loss time will be startup loss time plus the clearance loss time. So startup loss time means I told you when it turns green, T0 is a time when it turns green. The first vehicle is crossing only at time T1. Second is crossing at T2. Third is T3. Fourth at T4. Five at T5 time. Okay. So the headway between the vehicle is T1 minus T2. And I can say how much will be the loss for the first vehicle. It is T1 minus T0, second vehicle T2 minus T0, etc. etc. So when I plot this, okay, so the delay for the first vehicle will be more, second somewhat like when the first vehicle enters, the second vehicle getting enough reaction time, right? So he may start his vehicle and he will get ready to enter. So as we proceed into the sixth or seventh vehicle, the delay will be minimum, or this initial delay will be minimum. So startup loss time will be sum of all this. Then let's see what is green time, effective green time. So I told you there will be startup loss, there will be clearance loss, right? So the effective, even though the time permitted for the vehicle to enter is G plus Y, okay, the effective green time will be this G plus Y minus the loss time. Right? G is the time A. There is no confusion in that. The vehicle can go through, right? Y, it is the clearance time. Okay. So the total time permitted is G plus Y. In that, there will be some kind of initial loss for the starting or for the reaction and starting the vehicle, accelerating the vehicle. So there will be startup loss time. There will be clearance loss time. So these two coming together as a total loss. Okay. So effective green time will be the total time permitted for the movement minus loss. So the total loss time is given as NL plus AR, where L is the loss time per phase. So one phase, the loss time will be L1 plus L2. Similarly, for the next phase, the loss time will be again L1 plus another. So what will be the total loss time? It will be this loss per phase multiplied by the number of phases. Plus, I told you there will be an all-right period provided at the end of each cycle so that any vehicle that got trapped inside the intersection area is getting an opportunity to clear. Okay. So that time is provided red for all the approaches. So that is why it's called all-right time. So the total loss time will be NL plus AR. Then the saturation flow rate. So I told you we are sharing the time. Okay, so we are providing green only for a particular time. We are not providing it for the entire 1 hour. So this 1 hour time is being split into different approaches. Whereas if you assume that the entire 1 hour period is being allotted for the vehicle to move, what is the maximum number of vehicles that can cross the intersection? What is known as the saturation flow rate. Okay, so it is nothing but headway is the time difference between two vehicles crossing the stop line. First vehicle and the second vehicle, the time lag between the two vehicles crossing the stop line is what is known as the headway. So, for example, if say the headway is 1 second, okay, so how much will be the saturation flow? in a hour, there will be 3,600 seconds, right? The headway is only 1 second. How many vehicles can cross? 3,600 divided by h, 1 second. So, which means 3,600 vehicles can pass through the intersection area. So, capacity of the intersection is given as saturation flow into this effective green time divided by the cycle length. So, there is a question arises.
Excuse
Can
me,
I
ma'am.
go on? Yeah.
Ma'am, we've got 10 minutes more. This is the last 10 minutes. And we have some questions coming up. So, how we going? Can I get into the questions or?
That's fine. After 10 minutes, can I engage questions or?
No, ma'am. This is the final 10 minutes. We'll have to wind up by 3:45. Now it's 3:35. 2 minutes past 3:35. Right?
Okay, 5 minutes. Yeah. In 5 minutes, I will try to complete and then answer questions.
Okay, ma'am. Okay.
So the optimum cycle time as per Webster's method is given as 1.5 L plus 5 divided by 1 minus sigma V is critical. So, okay, we will do a problem, then I'll explain each of these what are this. So let's do this numerical example. A fixed time two-phase signal is to be provided at an intersection having north-south and east-west flow. So there is vehicle in the north-south direction. There is traffic movement expected in the east-west direction also. Design of flows from the various arms are being given here. The saturation flow is also being provided. You're asked to calculate the optimum cycle length as per the Webster's equation and also find the corresponding intervals, signal intervals, green interval, yellow interval, or amber interval, red interval. Then another thing is given in the question is loss per phase is 2 seconds. The initial loss plus the clearance loss is 2 seconds. And the yellow interval or the amber period is given as 2 seconds. So let's do this problem. So the first step is you have to determine how many number of phases are to be provided. So it is being provided the question like it is two-phase signal. So there is no right turn or left turn traffic being provided here. So directly we can say like north-south can be clubbed together into one phase. East-west can be clubbed together into another phase. So first of all, the first step that we have to do is we have to determine the number of phases. Okay. Then here we have decided it is north, south and east west. Then second step is you have to find the V by S ratio. Okay. So there is the actual volume existing there in this approach. Then there is saturation. So for the ideal condition, what will be the flow? What will be the flow? Okay. So to find the critical lane, you have to get this V by S ratio. I'll say like this. For example, I have 1 hour period. Okay, 1 hour is my time. I am sharing between two approaches. The traffic volume on both the approaches are same. So what I will do? I'll allot 30 minutes to one approach, 30 minutes to another approach. But on the other hand, okay, there is 750 vehicle in one approach, only 250 in another approach, 75%, 25%. So for the entire 1 hour, 75% of the time I will be allotting to one and 25% of the time I will be allotting to the other. So the green time allotted to a particular approach depends upon the volume there. Okay. Again, we have to compare it with the existing condition where what is the saturation flow or the maximum flow that can happen. That depends upon the number of lanes there, where there is any bus stops nearby or the channels or like left turn, right turn, how many lanes are being provided. All these situations affect the saturation flow. So here what we have to find here is we have to find the V by S ratio. V and S has been given. So you can find what is V by S ratio. Then I told you we are clubbing north and south together. We are clubbing east and west together. So north and south, we are getting V by S ratio, two values of V by S ratio, and for the north direction and for the south direction. So for these two values for which we have to design the signal, we have to design the maximum value. So of these two, I have to take the maximum which is 0.33. In a similar way, I am clubbing east and west together. So of these two, the maximum V by S ratio is 0.25. So V by S critical will be the sum of these two, 0.33 plus 0.25, which is 0.5. Next is you have to find the loss time. So I told you the loss time will be loss per phase into n, number of phase plus already period. So it has been given in the question as loss per phase is 2 seconds. Already period is nothing being given in the question. So you can say that's 0. So loss per phase is 4 seconds. Then step 4 is you have to determine what is the optimum cycle length. So this is the equation that has been given by Webster, where L is the total loss. So we found it to be 4 seconds. Then in the denominator, you have another term that is sigma V by S critical. So we are clubbing these two movement north south into together, right? So from this, I have to take the maximum value. From the other direction, I have to take the maximum V by S. Then you have to sum those values together, which will give you the V by S critical, sum of V by S critical. So when doing, you will be getting 26.19 seconds. So usually it's a better practice to provide the signal cycle length to be multiplied by. So I'm getting 26.19. I'm rounding it off to 30 seconds. Nothing wrong if you're putting 26, there's nothing wrong in that, but usual practices we used to leave it in multiples of 5. And another thing you have to take care is it should not exceed 120 seconds or 2 minutes. If it is crossing 2 minutes or 120 seconds, then you have to limit that to 120 seconds and then go for green splitting. So the total time cycle length required is 30 seconds. And how it need to be split among we have two phases. On what basis we need to split among these two? Okay. So for that, we have to find the effective green time. So which will be the total cycle length minus the loss time. So that will be the time where the vehicles are getting opportunity to enter into the intersection area. So which is 26 seconds, which can be shared among phase A and phase B. Okay. Or here we are taking north-south phase and east-west phase. So you have V by S, the maximum V by S value for north-south, that divided by the sum of V by S critical multiplied by the effective green time will give you the green interval in that particular direction. We're getting 14.79. I'm rounding it to 15 seconds. The other one is 11.21, which is up to 11 seconds. So 11 plus 15 together, it should be 26 effective. So please take care of that. It should not be 27 or it should not be 25. So you have to round it off. Then next is you have to draw the phasing diagram. Phasing diagram, say if you are taking a graduated scale, the length of that scale will be your cycle length, okay, 30 seconds. Now we are deciding how it needs to be split among these two signal phases or these two phases. Okay, so first let's consider the north-south phase. So we have already found that green interval is 15 seconds and amber period is 2 seconds. I'm providing these two. Then next is how much will be the remaining. It will be given as red. So it is 30 seconds minus 15 minus 2, which is 13 seconds is the red in the north-south direction. So when 15 plus 2 for north-south direction, 15 plus 2 is the 17 seconds is actually the time which is permitted for the vehicle to move in the north-south direction, right? So that time I should restrict the movement in the other direction, east-west direction. So what will be the red? This corresponding time will be red for east-west phase. Then after that, I can allot the green interval for the east-west phase, which is 11 seconds. So this is the American way of representing. There are different ways of drawing the phasing diagram. Whereas in Indian practice, after red, we provide 2 second amper time. Okay. UK practice, there is 2 ampere being provided. One is after green, there is 1 ampere, and after red also you will be giving red amper. This amper period will be different. But here I'm for the first problem, making it simple, I'm just providing only 1 ampere, 1 ampere interval, that is after the green. Okay.
Okay, ma'am. Hello, ma'am.
Yeah.
So it's 3:45 now. Shall we get into the questions and then wind up?
Yeah, fine. Thank you.
Yeah. Ma'am, first doubt is that Srisha has asked, a simple flared intersection Does it come under unchannelized intersection?
Simple flare intersection.
Does that come under unchannelized intersection?
Okay. So that again depends upon how we are arranging it. Okay. Yeah, flare can be with channels and without channels also we can provide. Okay. So as I told you, I have shown you one example on the intersection when discussing the unchannelized intersection. So there, it's a kind of flared one, but it's not channelized. So there can be flared intersection or the flared one, which can come under the unchannelized intersection, but it will create a lot of confusion. So to avoid that, it's better to provide channels like rotary, and we can provide the median, thereby we can accordingly deviate the traffic. Is that clear to her?
It should be, ma'am. Then we have a question. What is meant by pavement engineering? The question from
Pavement engineering. Yeah, fine. So this in your transportation engineering syllabus, you are actually studying transportation roadway as well as airway. So keeping airway apart, in the transportation engineering, we are covering two, like broadly we can classify. One is traffic engineering, where we are discussing the geometric design of highways. In designing the geometric design, or in designing the highways, we're using the different traffic characteristics and things like that. And also we are studying the different traffic parameters at macroscopic and macroscopic level. That is going on to the pavement engineering part. We are seeing what are the different materials, the suitability of that for highway construction. So we have to study the different materials to be used, what are the properties of each of these materials. There is standard testing procedure and there are standard values. If it is satisfying that only, then we can use that for the construction. Then under the pavement construction, again, the different design methods are there. Pavement design methods accordingly. There are different types of pavements like flexible and rigid pavement, and also the number of layers that we provide, the thickness that we provide, all depends upon the traffic load coming over there. It also depends upon the properties of the subgrade. So depending on that, we will decide what type of pavement it is, what should be the number of layers to be provided, what's the thickness of each of these. So all this comes under the pavement engineering part.
Okay, ma'am. Since we've run out of time, that's all. That's all we'll take from the questions. Rest of the questions we'll be sending it to you, ma'am.
Yeah. I'll be answering it.
Yeah. Okay. So thank you very much for the session, ma'am. It was a really good session to listen to, actually. Since it was transportation, traffic signals, all those things were coming in. It was really very well explained. And on behalf of all the students and attendees and SR, I thank you very much for the